Bonjour, mademoiselles. Je m'appelle Hunter, and it is hot in here. But no, this is really not a fan, so. Anyways, today I'm here to talk about chromatography to you. Chromatography is a scientific technique which is one of the most widely used analytical tools used today for separating mixtures and identifying components. Chromatography is all based on the polarities of compounds and elements. Before I explain that, let me show you this. Chromatography is going to have two different phases, a stationary phase and a mobile phase. In our experiment today, our stationary phase is going to be this plate. And on our plate we have labeled a line which is 1 centimeter above the bottom with 6 different places where we're going to put our 6 different dyes. And we have labeled them 1, 2, 3, 4, and 5 in our unknown. Now for chromatography to work, what we're going to do is we're going to take our dyes and spot them on our plate. If they are polar, then they will move up the plate. If they are non-polar, then they will remain more stationary. And this is because whenever a compound or an element is polar, it's wanting to gain or lose electrons in order to attain a balanced state. So if it's wanting to gain electrons, it's going to be more energetic trying to attain that electron, and therefore it will be the mobile phase and move up our plate. But if it's already in a balanced state, it doesn't need to gain or lose electrons, and it will remain more dormant. And we will take that into consideration in our experiment today. Now, as we do our chromatography experiment, what we're going to do is take these little glass rods, we're going to dip them in the dyes, and then put a dot of it on our stationary phase, which is our plate. Now, as you can see, I've already done a couple. So what we're going to do is dip the glass rod into the dye, make sure to get a little bit of them out, and put a dot of it on the paper. Like so. Then we're going to move to our next dye, which this is actually our unknown value. Place the glass rod in here. Make sure we get a little bit, and then we're going to put a dot of it on our plate, like that. And then we're just about ready to make sure that everything goes well. Stop. Now that we have finished spotting our paper, as you can see, we have 6 dots for our 5 solutions in our unknown. It's time for us to see which ones are polar, which is the chromatography experiment. So what we're going to do is we get a large enough beaker to make sure that this won't curl, which would curl or bend or anything like that, because that would affect our results and make them inaccurate. And this solution is actually H2O 1-propanol acetone. So what we're going to do, we're going to carefully put this down in the beaker, like that, and then we're going to take a strip of our highly intense laboratory equipment and cover the top. And doing this is going to lead the spots that we have made to run up the mobile phase, and therefore we will be able to determine which spots are polar and which ones are not, and thus which dyes are polar and which dyes are not. well now that it has been about 10 minutes, it's time for us to look at the results from our experiment. Alright, so based on our sample spotting on the TLC plates, we can see that the solvent line is the line where our solvent ended, and the spots, wherever they may be, the distance to those and the distance, we're going to measure all of those in centimeters. So what we're going to do, as you can see on our plate right here, our stationary phase, the solvent line stops at about right here. So we're going to measure this and we're going to record it in our notebook. And that is 4.2 centimeters. So the distance our solvent traveled was 4.2 centimeters. And we're going to need this measurement for when we calculate our RF values. So now what we want to do is measure the distance of how far each one of our dye spots moved. So again, we're going to measure them and record them in our notebook. So our first spot is just and remember this time we're going to the line where it started and not the very bottom. So this first spot traveled 2.3 centimeters. And our second one, our green value, which actually traveled the furthest, which means it's the most polar out of, or on this solvent, traveled 3 centimeters, or 3.0 centimeters.
It'll be 4.5 centimeters for the solvent traveled, and for the methyl red it would be 3.0 centimeters. And this is the distance of the dye traveled, and you divide it by the distance of the solvent traveled, which will be 0.67 centimeters. And for the green, it is roughly 3.4 centimeters. And if you divide that by 4.5, it will be 0.76 centimeters.
So 5 centimeters. .5. And we have to divide it by 5. .7. Centimeters. Almost 3.5 also.